Hello everyone, this is day 18 of the 30 days of fundamental series. So here we'll be discussing about OpenID Connect and the different grant types. In the previous video, we have discussed about OAuth, which is an authorization protocol. So when OAuth is definitely developer friendly and then being used from a very long time for a lot of mobile application. But then it has a limitation on authorization. It can only do authorization. Now, how do you compete with applications or protocols like SAML, which is an authentication protocol? That's where one layer on top of OAuth is OpenID Connect. So here we are going to understand what OpenID Connect is and how both are linked and what are the different ways in which the token exchange happens. So first, OpenID Connect is an authentication layer built on top of OAuth 2.0. While OAuth focuses on authorization, OpenID adds the crucial element of authentication. It helps you prove who you are. Think of it as OAuth allows an application to access your photos on a service like Google Photos without giving you the application, your Google password, for example. OIDC, on the other hand, allows an application to verify your identity through Google, again, without sharing your password. So one is giving the application, right, what they would need. In both the cases, the password is not being shared. Okay, one is granting access to resources, other is helping you verify the identity. And the moment we say verify with identity, automatically authentication comes into picture. Okay, so some of the key concepts. First is an identity provider, where you have products like Okta, Ping, OneLogin. All of these are identity providers. Okay. Let's draw an identity provider. We call them as IDP. Then we have a relying party, the application that relies on the IDP. So this was the application. Any application that would want to, that a user would want to log in. Okay. Authentication. This is a process where the user is proving who they are. Authorization. Once the authentication is done, what level of access they would get. ID token. A token that contains claims. If you remember, in the SAML world, we had assertion. Assertion is a XML format, which actually is helping you authenticate a user. There are details inside which will help you authenticate a user. Similarly, a token, ID token, is what helps you authenticate a user, prove a user's authenticity. Access token, a token that grants the client access to the protected resource on behalf of a user. So access token primarily comes on the OAuth world. That is one of the main difference between OAuth and OpenID Connect. Here you have access token. Here you have ID token. This is authorization. This is authentication. The main difference. Right? UserInfo endpoint is a very important endpoint where the moment these tokens are exchanged, right, the client, which is the application, would need user information. Then based on the user information that it would get first name, last name, email, it is actually going and creating an account for you and logs you inside the application. So this endpoint is that particular endpoint inside the IDP that is giving those user information. Ideally, there are three endpoints. We have the auth endpoint, token endpoint, and user info endpoint. So these three endpoints play a major role in all the transaction that is happening. Eventually, the user info endpoint is the one which is giving the user, the client, the application, details about the user for it to go and create a profile and log you in. So these are different key concepts. So let's quickly summarize. Identity provider, an authority that authenticates the user. A relying party is the application that is actually looking to consume the resource so that they can grant the user access. Eventually, they'll perform authentication, whereas they will prove the user who they are and then grant access to the right resource through an ID token or an access token by fetching the information from a user info endpoint. So OIDC flow, let's, so there are basically different steps involved in the overall flow. So we'll discuss about some of the process. So first you have a client, which is the application itself. And then you have three boxes. Okay. Let's say auth endpoint, token endpoint, and user info endpoint. Imagine a user tries to log into any application. So the client is the one who's going to go to the auth endpoint and request for certain details. The auth endpoint is going to reply back with a code. Client goes back to the token endpoint and says, hey, now take this code and give me a token. So code to token exchange. And this guy is going to give them a token. Using this token, it goes to the user info endpoint and fetches the user details. And using those user details, it is going to create a user profile. So here in the example, you will see client is doing the back and forth most of the time. Okay. So authentication request is the where the relying party redirects the user to the IDP's authorization endpoint, which is this first one. Then there is authentication and authorization that is happening where a user is prompted for a username and password. You put your username and password, authentication is done. Response is sent, which is the authorization code. This is the flow one, and this is flow two. Okay. So then we have the token exchange. The relying party exchanges the authorization code for ID token and access token by making a back channel flow. Now there is something called as front channel and back channel. I'll quickly cover them. So when you say front channel, any process that is happening on the browser level, that is called front channel. And anything that is happening on the server level, that is called back channel. So flows like auth code flow, which we'll be discussing, has front channel, back channel. Flows like implicit, then resource owner, password grant, client credentials do not have a back channel. Okay. So then this exchange happens, user information, the relying party can use the access token to call the user info endpoint to retrieve additional user information. And then the RP validates the ID token and establishes a session, which is this one. So this is the basic flow. And this flow or grant type where there is a code to token exchange, right, is called authorization code flow. There are basically four types of flows. The first is authorization grant code. Okay, this is most secure recommended grant type because there is a code to token exchange. Two-step validation is happening. Okay, so OIDC leverages the multiple grant types in which one of them is authorization grant flow. And whatever I showed few minutes ago, that is exactly the same flow. Then comes the implicit, a simplified flow where ID token is returned directly. So here the client goes to the authorization endpoint, request for a token, and this guy gives the token back. There is no code to token exchange. Okay. Then you have the hybrid grant, which is a combination of authorization code and implicit, allows the RP to receive some tokens directly in the response and exchange an authorization code. Then we have the client credential, which is very commonly used in tools like Postman. If you have used Postman, you will go set up a client ID secret on the top in environment variable, right? And then sometime in the body of the request also you will post, you will send this. So here, primarily used for machine to machine. And the important thing is client ID and secret is used or is passed, which makes it unsecure. So hence, if you are doing a basic testing or basically testing of any application, this is used, but enterprise level application, authorization code is the go-to solution. So if there is an application team where they're like, hey, what should I use? Auth code or implicit, auth code is the recommended path. Unless if they really want to use an application internally in a VPN, then they can go with implicit. But primarily for testing and all, client credential is fine. Then we have resource owner password grant, which is a deprecated flow, similar to client credential, This is also a flow where it uses username and password to kind of authenticate the user. Okay. And then an important one, auth code grant with Pixie, proof key of code exchange. Here, so if this is auth code with auth code, Pixie is a layer on top of it. And then you have DPOC, proof of position, on top of this also, right? Here you have, it uses a code verifier and here it uses a certificate. So these are basically advancement in the auth code layer. So choosing the right grant type, auth code primarily for single page application, mobile application, right, with Pixie. Authorization code for all the web application, mobile application, server-side application. Client credential for machine-to-machine authentication. And implicit, you need to avoid due to the security concern as well as the resource owner password grant. So this summarizes OpenID Connect. I mean, I've just tried to kind of skim through a lot of concept in a very short period of time. So basically, OpenID provides a standard way to authenticate a user. It is an authentication protocol built on top of OAuth, where there are four different grant types. You have the auth code, implicit, resource owner password grant, client credential, and Pixie being a layer on top of the auth code. And this summarizes the day 18. I'll see you in day 19. Thank you very much.